Dependent events. Now, what are dependent events? Now, you suppose there is a hat which contains five red balls and three blue balls. Okay, so they are kept in a hat. So these two are kept in a hat. Now, one ball is randomly chosen. Its color is noted and is then put aside. Means it is not put back in the hat. Now you are getting a second ball. Okay, the second ball is then randomly selected. What is the chance that it is red? So see, the chance of this is red, that depends on what was the color of the first ball. So see, if suppose if the first ball that you are taking, if the first ball suppose was red, if the first ball was red, so the probability of getting second ball red, that will be how much? See, now the first, sorry, the red is already been taken out. So how many are left? 4 red and 3 blue. So that means 4 plus 3, that is 7. Okay. Now if the first ball same, if the first ball was blue. Now if the first ball was blue, so what is the probability of getting second, which is red? So that is, see, second red. So means, see, initially there was how much? There was 5 only, but the first ball is blue. First, the first ball is blue. Okay, so this will be uh, if the first ball was blue. So see how many blue balls are left now? 2, but the red is 5 only. So this will be 5 upon total is 7. So 5 upon 7. So see, the probability of the second red, that depends upon the probability what was the color of the first ball. So these are called the dependent events. Okay, so these are dependent events. Okay, and so what do you mean by dependent events? So two or more events are dependent if the occurrence of one or more event does affect the occurrence of the other, as you can see over here. So the probability of second red was depending upon the color of the first ball. Now if you consider if you consider A and B, if A and B are dependent events, if A and B are dependent events, okay, so what's the probability of A intersection B? So probability of A intersection B will be given as probability of A times probability of B. Now given that A has occurred. Okay, so that is how you give for the dependent events. And also in general, when the experiment involves sampling. So see, this is only for the sampling. Experiment involves sampling. So when this is without replacement, placement, as we have done, as you have seen, this without replacement means when the ball was taken out, the first ball was taken out, it was not put back. So these will be the dependent events. So these are dependent events. Okay, now when this is with replacement, so that means the ball which is taken out will be replaced or put back in the hat. So these will be the independent events, but in this section we are discussing the dependent events. Okay, now let's study this with some examples. So we will do some examples. Okay, so the first example is over here. Okay, now see, two students are chosen at random from a group of 3 girls and 5 boys, all of different ages. Find the probability that two students chosen will be 2 boys, 2 girls, the eldest 2 students. Okay, let's start with this. First of all, see how many girls are there. There are 3 girls and 5 boys. Okay, so our A part is 2 boys. So the first boy will be selected. What's the probability of the first boy? See how many boys are there? 5. So 5 by 8 times. Now second boy. Now see, first is already selected. One boy is already selected. How many are left? One only. So the number of boys left will be 4 and total will be 7. So this is 20 by 56. You solve it further, you will get 5 by 14. Okay, now the B part. 2 girls. So see, first girl will be selected 3 by 8. Now, when the one girl is already selected, the probability of second will be, that will be 2 by 7. So this will be 6 by 56, which is equals 3 by 28. Okay. Now they are saying the eldest 2 students. Now see, they all are of different ages. So eldest 2 is obvious, there will be just 2 students who will be elder. Okay. So C part. So when we are selecting the one eldest student, means that will be 1, sorry, because there are 2, so that will be 2 by 8 into, when 1 is already selected, 1 is left, so 1 by 7. So this will be 2 by 56, which is 1 by 28. Okay, so that's the question. You can see this. Now moving on to the next example. So here is the next example. Okay, now yes, of the students in a class playing musical instruments, 70% are female, 20% of the female and 30% of the males plays guitar. Now see, 70% are female, that means 30% are male, and 20% of the females and 30% of the males plays guitar. Find the probability that a randomly selected student is a male and does not play the guitar. Okay, now B, plays the guitar. See, what you will do in this question is, first of all, we have to make a tree diagram. Okay, so first will be, let this be a male, let this be a female and a male student. Okay, so female are 70%, we write 0.7, and the rest will be male, 0.3. Okay, now out of the female, 20% of the female, they plays guitar. So see, G, I am writing the one who plays guitar, and this G complement or G dash who does not plays guitar. Okay, so right here G, 20% of the females means 0.2 plays guitar, and who are not playing guitar, G dash, that will be 0.8. Okay, similarly for males who plays guitar and who doesn't plays guitar. So the one who plays guitar is 30% of the males plays guitar, so this will be 0.3, and who doesn't plays guitar will be 0.7. Okay, so first our A part is, you have to find the probability, means the randomly selected student is a male and does not play the guitar. So that's the probability of male intersection G dash. So male who does not play the guitar. Okay, now if we look at the tree diagram, so see, this is male and does not play the guitar is this. So this will be 0.3 times 0.7. So the answer for the A part is 0.21. Okay, now for the B part, plays the guitar. Now they are saying they plays the guitar. Matlab that person plays the guitar. So that could be a female playing a guitar and a male playing a guitar. So that is, if we write this, probability of male playing guitar plus probability of female playing guitar. So if we look at the tree diagram, see female, oh, we have written for male playing guitar, so let's do this. So male playing guitar is 0.3 times 0.3 plus a female playing guitar will be 0.7 into 0.2, 0.7 into 0.2. This is 0.9 plus this is 0.14. Okay, so total this will be 0.23. That's the answer for this question. Okay, moving on to our next question. Okay, this is the next question. Now see, a football tournament consists of 20 teams. So actually there are 20 teams participating in a football tournament. Team A is currently in the 8th place. So you can see this team A is currently in the 8th place on the table. So means its ranking is 8. Out of 20, its ranking is 8. It has 20% chance of winning and 50% chance. Sorry, this is chance actually. This is wrongly written. CHANCE. Chance of losing against of losing against any team placed above it. Okay. If a team is placed below it, team A has a 50% team A has a chance of winning and 30% chance of losing. Find the probability that the team A will draw its next game. So see, what we have to look in this question is that, see, first of all, the team A, this team A is in the 8th place. Okay, so when it is in the 8th place, so how many teams are above it? So there are 7 teams which are above A. Above A means ranking above A, and there are 19 teams. Sorry, not 19. Sorry for that. There are 12 teams. 12 teams which are below A means ranking wise there are 12 teams. Ranking wise, team A is on the 8th place. 7 teams are above A and 12 teams are below A. Okay, so now we have to divide it among, like, the opponents. Okay, now see, opponents opponents and the result. So let's make a tree diagram so you can see this as the opponent. So here are the opponent. So if the opponent is above A, so what is the probability? 7 by 19. So see, why 19? The total team are 20, but since we are taking the teams which are playing against A, so A cannot play against itself, so that's why there are 19 teams. And if it is below, what will be the probability? That will be 12 by 19. Now, what are the chances? Chances of see, there are actually 3 chances. They could win. They could either, you can write over here results. Okay, so for this you can either win, draw, or lose. Okay, so see, it has 20% chances of winning and 50% chance of losing against any team placed above it. So 20% chance of winning over here will be 0.2. Of losing they have given 0.5. So what will be the chance of drawing? Means the match will be draw. So this is 0.7, so this will be 0.3. Again for this is for winning. Just a second. This is for winning. This is to draw and this is to lose. Okay, lose. Losing. Okay. Now see, the team A plays, it has a 50% chance of winning and 30% of losing. So 50% chance of winning means 0.5, losing is 0.3. So what's the chance probability of that the match will be draw? So 0.8, this is 0.2. Okay. Now this is 0.2. Okay, what's the question? Find the probability that the team A will draw its next game. So see, probability of, this slide with another pen, probability of draw. Okay, probability of D. So this is the probability of playing with the above team intersection the draw, plus probability of playing with the team below intersection draw. Okay, now let's go in the tree diagram. Above is 7 by 19 and draw is 0.3. Okay, so this is 7 by 19. See, 0.3, we can write 0.3 as 3 by 10. Okay, just for the simplification, into 3 by 10 plus below and draw. So this is below 12 by 19. 12 by 19 times draw is 0.2. Again 0.2 can be written as 2 by 10. Okay, so this is into 2 by 10. Okay, so this is 21 by 190. Let's solve it. Plus this is 24 by 190. Okay, you can take the LCM as 190 only. 190, since the LCM is 190, so this will be 21 plus 24, which is 45. On further solving, you will get 9 by 38. Okay, so this question is done. So now let's move to the last question of the video. So this is the question. Okay, I hope you can see this clearly. Now, in a class of 25 students, 11 students participate in extracurricular activities. Suppose 3 students are randomly selected to be on the students' representative council. Find the probability that at least 2 students selected for the council also participate in extracurricular activities. Okay, see, solution for this is, see, let E represents. So I am representing E for the students. E is representing for the students who participates in extracurricular activities. Extracurricular activities. Okay, and similarly E dash will be the one who does not participate in extracurricular activities. So I will be using E and E dash. Okay, now, so there are 3 students who are selected. 3 students are selected. Okay, so see, uh, no, let's write down this. So E is how much? E is 11 and E dash will be 14. Okay, E dash means, E means the students who participate in extracurricular activities is given 11 and the rest 25 minus 11 will be, E dash will be 14. Okay, so let's start with here making the tree diagram. So see, for the first student, okay, so let this be from extracurricular activities and not from the extracurricular activities. So E, we know that it's 11, total is 25, 11 by 25, and this is 14, 14 by 25. Now, for the second student, again, he might be from extracurricular or from not. But the thing is that here the probability will change. If the E means from the student from extracurricular activities is already taken into account, so this will be means already chosen, so this will be 10 and total will be 24. But E is chosen, E dash is not, so this is 14 by 24. Similarly for E dash, we again have E and E dash. Okay, if the student from E dash is selected, so this will be, because E is already there, 11 by 24, and E dash is selected, sorry, this is E dash. E dash is selected, so this is 13 by 24. Okay. Now for the third one. Third again, he might be from E dash. Okay. Now when the student from two E's are selected, means extracurricular. So how many are left? 9. How many are left? 9. So this is 9 upon, but now 2 are selected to 23. Okay. So 1 E dash. So E dash for the E dash, now there are 13 by 23. Okay. So now for this E dash, we have again E and E dash. Okay. Now when 1 E is selected, E dash, so this E will be 10 by 23 and this will be 14, 13 by 23. For this E, again E and E dash. Okay. So E dash and E, again this will be, 1 is selected, so this will be 10 by 23, 10 by 23, and E is selected, so this will be same, 13 by 23. Okay, so over here again this E dash, E, and this is E dash. Okay, so if 2 E dash are selected, this is not, so this will be 11 by 23, but over here 2 E dash are selected, so total was 14, 12 by 23. Okay, so this is our, as you can see, this is our tree diagram. Okay, now what's the question? Now we have to find the probability that at least 2 students selected for the council also participate in extracurricular activities. Now 2 students selected for the council, at least 2 students. That means it could be 3 also. Either 3 or 2, they are from E. Okay, so see, the question is you have to find probability. This is at least 2 students. At least 2 students selected also participate, or you can say from E, also participate in extracurricular activity. So see, this is probability of, see, you can take triple E because at least 2 means all 3, plus you can take probability of 2 from extracurricular activities, 1 is not, plus probability of, like, 1 is from extracurricular activities, other one is not, and a third one is there, and the fourth is first one is not there but the other 2 are there. Okay, so now let's move to the tree diagram. Okay, let's take the reference for the tree diagram. Triple E is this 11 by 25, 10 by 24, 9 by 23. So 11 by 25 into 10 by 24 into 9 by 23. Okay, plus now E dash. So this is E and E dash over here. So this will be 11 by 25 into 10 by 24 into 13 by 23. Okay, now this is E dash E. So E dash E. So this is 11 by 25 into 14 by 24 into, this is 10 by 23, 23, and the last one is E dash EE. So 14 by 25, 11 by 24, 10 by 23. Yeah, so this is 14 by 25 into 11 by 24 into 10 by 23. Now this question is almost done. We just have to solve these things. So see, when you solve this, you multiply all these, 11 into 10 into 9. So what you will get is 990 upon 13800, plus this will be 1540 upon 13800, plus this will be 1540 upon 13800, plus last one will be I think this will again will be 1540 upon 13800. Okay, so the LCM is same, so that will be 13800. Now you add these four, 1 2 3 4. So you get you will get 5610. You further simplify this, this will be 187 upon 460, which is equals to 0.407. So that will be the probability of the 2 students who participate in, at least 2 students who participate in extracurricular activities. So students, that's all for the today's video. I'll be coming with more such videos, so please do like and subscribe my channel, and also thanks for watching.